Hello and welcome to a lesson about existential quantifier exploitation. I would like to begin by having you consider this following argument. In this argument, we won't yet use existential quantifier exploitation, but I want you to think about it. The first premise says all doctors are intelligent, and the second premise says Bill is a doctor who golfs, and we are able to infer from this that some golfers are intelligent. Obviously, we simply use universal quantifier exploitation and infer that Bill is intelligent. Before this, we need to simplify DB, and then we're able to infer that Bill is intelligent from 1 and 3 with EQE, and finally we are able to, after we also simplify GB, we are able to infer that there is someone who is both a golfer and is intelligent. Okay, so this follows from 4, 5, EQI. EQI was the first rule we learned. Now, one thing I'd like you to notice here is that if all doctors are intelligent and we know that there's a doctor who golfs, we are able to infer that some golfers are intelligent. Okay, so in this one, we did not need to worry about existential quantifier exploitation, which we're going to in the next one, because we are given someone, Bill, who is both a doctor and Bill golfs. And what if in this kind of thing about Bill, we knew something else? Look at this second example. Some doctors are surgeons. All surgeons work in hospitals. Any doctor who works in a hospital works hard. It follows that some doctors work hard. Give yourself a moment to notice that in ordinary thought you would find this argument valid, of course. Now, our problem is with the rules we have so far. Doctors who are surgeons that are said to exist by the first premise, we don't know any particular one of them. We don't know Bill, for instance, or any other doctor. We know that there are some doctors that are surgeons. This would mean, with the other premises, that those doctors, whoever they are, who are the surgeons, they must work hard, right? This would follow from together with the other premises. So here is what we can do. Not that we know this, but suppose for a moment that we know that Amy is one of the doctors that is mentioned in Some Doctors Are Surgeons. Okay, Amy. And Amy is both a doctor and a surgeon, and she is one of the persons mentioned by the existential quantifier, let's say. I mean, we know there are persons like this. The first sentence says that there are. Let's just randomly pick any one of them and call her Amy. Okay. And then we can do the following. With 2 and 5, we are able to notice that Amy would have to work in a hospital. And so that would make her someone who's both a doctor and who works in a hospital. 4-6 conjunction. And since this means that Amy would have to work hard because of premise 3 and 7 put together, now I know of Amy, this supposed individual, that Amy is someone who works hard. Okay, now 4, 8, EQI. I abstract away from Amy, and I notice that someone works hard. Now, notice that in this line 9, the word Amy, or A, the letter A. It doesn't even appear. There's no A there. I could have picked, instead of A, I could have picked any other letter, for instance, B, and I would have been able to go through exactly the same thing, and the last line would be the same. I could have picked any other letter, C for Charlie, and the last line would exactly be the same again. What does that mean? It means that as long as there is some individual who is both a doctor and a surgeon, which the first premise says there are, I would get the same result. Since my result doesn't depend on my assumption, DBDC or DASA, my assumption doesn't depend on that particular, this conclusion at 9 does not depend on the particular assumption I made at 4 and 5, I can actually take it outside the subderivation. I can carry it outside because it is not an assumption that depends on the particular name I used. All I need is any name whatsoever, and the first premise already tells me that there is such a person who is both a doctor and a surgeon. So that wasn't what I was assuming. I was just assuming that the name Amy works to refer to one of those. Okay, so 4 through 9 is independent then from the assumptions at 4 and 5. Excuse me, the final line then is independent from the assumptions made at 4 through 9. So it can be carried outside, and it's that's how the rule EQE actually works. Now, before I, in the next page, talk to you about the rules, restrictions and stuff, but let's do this really quickly here. We can see that we now learned a rule for using existential quantifiers. It's called EQE, existential quantifier exploitation. We do it by introducing a new name for or an artificial name, a name that we just made up, for one of the things that the sentence, existential quantified sentence, says it exists. Okay, and using that method, we prove something that actually doesn't use that name in the end. So notice that this line here, 10 or 9, doesn't use the name Amy. Okay. Now, this third slide shows you the abstract description of this rule. It says that you take what you do is you make a subderivation. This subderivation's assumption line has 2 lines, and the first line matches the restriction of your existential quantifier. The second line matches the body of your existential quantifier. You keep the predicate parts the same, but you switch the variable, whatever it is, with a constant, and that constant has to not appear anywhere before, and it has to not appear anywhere before, and has to not appear in the result, in the conclusion. Okay, now we're going to do one short exercise using our new rule, and then this will be the end of the video, because there's really not 10 minutes is the limit for these videos. Okay, now Charlie loves at least one of Bill's sisters. That's the existential quantifier we're going to exploit here. To do that, I will give a name to that person who's one of Bill's sisters. Okay, so S-A-B and L-C-A. Those are the assumptions, right? What I did is I called X A. I used the name A to refer to the X person mentioned. Now 2 and 3 with U, Q, E, what does that give me? It gives me that person I named A is a nurse. Okay, now because of that, it follows that there is a nurse that Charlie loves. That follows from 4, 5 EQI. And since the letter A doesn't even appear there, I'm able to take this conclusion outside this observation, and basically I'm repeating it, but because it doesn't feature the letter A, I'm able to carry it outside. And that's how that works.
Made with Doodlecast Pro.